Okay, question 40. It takes a certain amount of time for a certain number of moles of hydrogen to effuse out of a container. If it takes an unknown gas 4 times longer for half that number of moles to effuse out, what is the molar mass of the unknown gas? And so we're going to use Graham's law of effusion, which is the rate of the first gas over the rate of the second gas, is going to be equal to the square root of the molar mass of the second gas, which will be our unknown gas, divided by the molar mass of the first gas, and we'll call that hydrogen. Remember that rate is equal to the amount, or the number of moles, okay? So the amount per unit time. So for our hydrogen, why don't we say the rate is equal to a certain number of moles of hydrogen. We'll call that X since it doesn't tell us how much. And let's say it takes, 1 minute. And we could put in any time we want here, but let's just choose a certain number of moles of hydrogen in 1 minute. And then we compare that to the rate of the effusion of the second gas. Well, it says that the second gas takes 4 times longer, so it's going to be X over 4 minutes, but it says that it's only half that amount. So we're going to have to take that and we're going to have to multiply that by a half. So we have 1/2 times X over 4 minutes. And that's going to be equal to the square root of the molar mass of the unknown gas. We'll call that the molar mass of 2, divided by the square root of the molar mass of hydrogen, which is 2.02 grams per mole. Now it's just a matter of some algebra. Hopefully you can see that the number of moles of each of the gases cancel out. And when we shorten this, or simplify this rather, we end up with 1 reciprocal minutes divided by 1/8 reciprocal minutes is equal to the square root of the molar mass of our unknown gas divided by 2.02 grams per mole. Well, if we simplify that a little bit further, what do we see? We see that 8 squared, which is equal to 64, is equal to the molar mass of our unknown gas divided by 2.02 grams per mole. When you solve for the molar mass of the unknown gas, you end up with 129 grams per mole, and that is our final answer.